Good. We're looking at factoring expressions of the form of ax squared plus bx plus c. This is part 2. Let's look at another example. We have 6s squared minus 29s plus 35. Okay, so this example is slightly harder than the previous one, but not too bad. Alright, so essentially, first thing, we have to look for a common factor among all three terms. Is there a common factor among three terms? No. Okay. So, is it a simple trinomial or a complex trinomial? It's a complex trinomial. Alright. So next, what we're going to do is the following. If it's a complex trinomial, then in this case, we're looking for two numbers that when multiplied will give us what's 6 times 35, right? A times C, so 6 times 35 is 210. And when we add these same numbers, we want to get negative 29. Now, you may have done already some exercises, and you may notice that sometimes it's a bit hard, a bit difficult to figure out two numbers that will satisfy both of these equations, right? So, what we can do is the following. We can use a technique that allows us to decompose a number into its prime number. So in this case, first we know that the product is going to be positive, so that means both numbers will have to have the same sign. Either they're both positive or they're both negative. Okay, so here, let's grab the product and we can use the following. Let's decompose it into its prime numbers. So we can take 210. Alright, 210 is the same as saying 21 times 10, right? And 21 is the same as saying 7 times 3, and 10 is the same as saying 5 times 2. And that's it. We cannot further decompose these. These are all prime numbers. Okay, so now the next step is to do the following, right? We want to take these numbers, the 7, the 3, the 5, and the 2, and combine them and see if we can get something that will give us a minus 29. So for example, 7 times 3 is 21, 5 times 2 is 10, right? So 21 plus 10. 21 plus 10, that will give us 31. So that wouldn't work out because we're looking for negative 29. And besides, both numbers are, because our result here is going to be negative, both numbers will most likely have to be negative. Okay, let's try another combination. 7 times 5, 35, 3 times 2, 6. That might. 35 minus 6 gives us 29. But we can't really use it because, once again, let's look at this. Once again, right, we need to get negative 29. So, and they both have to have the same sign. So we won't be able to subtract them or get a difference. But how about this? Let's try these. Let's try these two. Let's try combining this. 7 times 2 gives us 14, and 3 times 5 gives us 15, right? 7 times 2 gives us 14, right? And 5 times 3 gives us 15. Alright, remember, we're looking for these two numbers, right? So look, we can combine these two. First, the product will have to be positive, so they can be either both positive or both negative. But since we know that the addition of these two numbers will have to be a negative 29, then we know that both of these should be negative. So negative 14 plus negative 15 will give us negative 29. So we found our numbers. Okay, so these are the two numbers that satisfy these. Okay, so now what we do next, we do the following. We use a technique called breaking up the middle term. So when we're factoring complex trinomials, we use a technique called breaking up the middle term. And so our next, let's continue solving this. So next we write, this becomes 6s squared. Now remember, we're breaking up this negative 29 into, we're breaking it up into negative 14s, right? negative 15s, right? And then let's just bring down the 35, okay? So if you notice, we broke up this middle term. That's why it's called breaking up the middle term. So we broke it in those two numbers, right? Because these two numbers satisfy these two expressions that we're looking for, these two requirements. Okay, so let's continue on. Now once we've done this, the next thing that we do is, and just let me just draw a limit here before we get confused, okay? So what we do now is the following. We take these two terms, and we group them. So we factor by grouping. So let's find what's common between these two terms, okay? Well, we find that these two, we can factor out the 2 out of them, right? So 2 is a factor of these, and then also s, right? So 2s. Let's open up the bracket, so this becomes 3s, right? Positive times negative, negative. 7 times 2 will give us 14s, and that's it. Well, we don't need to write the s again. How about between these two, right? Well, we can factor out the negative, right? And they're both divisible by 5, so we can factor out the negative 5, and that's it, right? So we open the bracket, negative times negative, positives, okay? So 5 times 3 will give us 15s, so 3s, right? And negative times negative will give us a positive. 5 times 7, 35, right? Let's continue factoring this now. These two expressions over here, right? They both have a common factor, and it turns out to be the binomial 3s minus 7. So let's factor out the 3s minus 7 from these two. So let me move this up a little bit. Alright, not too much. Okay, so next, let's factor out the 3s minus 7. Okay, so 3s minus 7 times 2s will give us this expression. So 3s times 2s will give us this expression. Then positive and negative, negative, and then 3s times negative 5 will give us this expression over here. So that's it. So we've factored this expression over here. We factored it, all right, and we factored using by breaking up the middle term, which is what we have been doing before. Okay, so here, this is just as a quick review, right? When sometimes it's hard to find those two numbers that satisfy this expression, then what we do is we can split the product, right? The product and decompose it into its prime numbers, right? The nice technique about this is that you don't have to worry about the multiplication anymore, since we know that any combination of these two numbers multiplied with each other will give us 210, and all we have to do is worry about finding a combination of numbers that will satisfy the addition of the two numbers. Alright, okay, so there's one more example on your handout. Okay, so continue doing the other examples, and there's one over here which is 49x squared minus 9. Okay, I want you to take a look at that, and we can deal with it next time. Now you may be wondering, is this so you may start like this. Is this a common? Is there a greater common factor among these terms? No. Is it a simple trinomial or a complex trinomial? Complex trinomial, right? So if it's a complex trinomial, it's of this form: ax squared plus bx plus c, right? We know that a is 49, right? What is the value of b? Well, the value of b is 0, right? And what's the value of c? Is negative 9. Okay, so you may notice already by using the flowchart that we can figure this out in a quick way. However, what I want you to do is to simply consider it as this expression, right? So we write this plus 0x minus 9. Okay, later on we'll learn how to quickly solve these, but I just want to show you that even if you didn't notice the pattern, you can still use the technique that we just learned to figure out the answer for this exercise. Alright, okay, see you next time.